Welcome to Knowledge Base. This question borders on the conservation of momentum. This is a question and we have options to choose from. I'm going to sort out the parameters as I read the question. We are told that a 2 kg ball moving at 6 meters per second. That means there is a mass, the first mass, m1, 2 kg, moving at 6 meters per second, the initial speed. That object collides with a stationary 4 kg ball. The second mass, m2, is 4 kg and it is stationary. It means its initial speed, u2, is 0. After the collision, the 2 kg ball moves at 2 meters per second. Remember, the 2 kg ball is m1, so its final velocity after the collision is now 2 meters per second. Let's call it v1. U for initial, V for final. Now we are told to find the velocity of the 4 kg ball assuming momentum is conserved. The 4 kg ball is the mass 2. We want to find its final velocity after it was hit by the 2 kg ball. That final velocity of the second object 2 is V2. We don't know the answer, and that is what we are looking for. We are also told in the question that momentum is conserved. When we say momentum is conserved, it means the momentum before the collision happened, or rather the sum of the momentum before the collision happened, is equal to the sum of the momentum after the collision has happened. Mathematically, we say summation of momentum, P, stands for momentum here. Summation of momentum before collision equals summation of momentum after collision. What is the formula for momentum? Momentum is simply the product of mass times velocity. So for each of these objects, we are going to look for its product of mass and velocity before collision and the product of mass and velocity after collision. We are going to look for the sum before and the sum after. What it means is that for the object 1, m1u1 represents its momentum before collision plus m2u2 represents the momentum of the second object before collision, and that is equal to the final momentum of the first object plus the final momentum of the second object. Now take note, the second object was stationary, which means u2 is 0. What it means is that this component here is 0, and the formula reduces to m1u1 equals m1v1 plus m2v2. All of these parameters are present in the question except v2, the final velocity of the second object, the 4 kg object, which is the velocity we are looking for. So we want to make v2 subject of the formula. You agree with me? It's very simple. If we move this to the right hand side, to the left hand side, it becomes m1u1 minus m1v1. That will be equal to this, right? So we can say m2v2, which is this one, equals this minus this. We are looking for v2, and it therefore makes sense to divide both sides by 2. Dividing both sides by 2, we have that v2 equals m1u1 minus m1v1 divided by m2. This is where we now plug in the values. Plugging in the values, we have m1 to be 2 times 6u1 minus m2. m1 is 2 times 2 for v1 divided by m2, which is 4. 2 times 6 is 12 and 2 times 2 is 4. So 12 minus 4 divided by 4 means 8 divided by 4. And of course, you agree with me that that is 2. So the final velocity of the 4 kg object is 2 meters per second. And it is very simple and straightforward. And that is a simple answer to the question, which means option B is the correct answer. If you understood this video and you enjoyed it, I have a simple one for you on the next page. Here we are told that a force of 20 Newton is applied to a body for 5 seconds. If the mass of the body is 10 kg, calculate the change in velocity. This is a simple hint here because we know that force is the product of mass times acceleration, and acceleration is the change in velocity divided by time. So we have a formula that says force equals to mass times the rate of change of velocity. If you use this formula, you can be able to get the change in the velocity. Put your answer in the comment section and I'll be there waiting for you. Thank you for supporting Knowledge Base and hope to see you in our next video.